Hi, this is Give Me a Milk. It's been a while, apologies for that. I hadn't meant to leave this long between videos, but better late than never, and I hope you enjoy this one. I'm playing this game online. It's at lookforlonger.com. Basically, you get this big picture, which you can zoom in and look around, and everything in the picture is the name of a London Underground train station. So the idea of the game, there's 75 to get. You have to guess every train station based on the picture. So some of them are more straightforward than others. For example, here there's an Angel, and there happens to be an underground station called Angel. So that's one correct. But some of them are slightly more bizarre and lateral thinking than others. For example, this one here is a wizard kind of casting a spell or something on these two people who are green, and the name of the station is Turnham Green, which is slightly bad pun, but there you go. So that's the nature of the game. So I got most of these, but there's a couple that I just can't get, and rather than just Google the answer, I thought it'd be interesting to see if we could interrogate the website that runs this to try every station until we hit upon the right answer. So that involves some scripting and some examining of network traffic, etc. So let's run Wireshark, which is a program for capturing the data that's gone on the network to this computer. So we'll select the wireless interface to capture, because I'm on the wireless network currently. So now Wireshark is listening to all the data going on the network, including anything in this game. So let's try experimenting. Let's pick one that we know the answer to. This one here is a picture of a farm drawn in chalk, and there's a station called Chalk Farm. So it's fairly obvious what this one is. So let's try submitting a wrong answer and see what we get for it. So in here I'll just put wrong answer. Wrong, obviously. But if we stop the capture now, and this is all the data that came to and from the computer in that time. So let's filter out just the HTTP requests, since it's a browser. And here it is, a post request. That means that the computer sent some HTTP data to a remote server, and the page it sent it to is called Game Answers Handler. So that sounds promising. Let's look at what got sent. So there's our wrong answer as part of the query. So there's various other things here. There's some codes and whatnot, but in there is the wrong answer. So let's copy that, and let's fire up a text editor, and we'll just make a note of things as we go along. So when we put in wrong answer, that's where it got put. G equals wrong answer, and then some other things in the query. So now let's look at what the response was. So the destination was this address, so the corresponding response is down here. And this is what it returned. Int result -1, int player total 0. Not sure what either of those are at this stage, but let's make a copy of it and put it in the text box here. Now let's put the right answer in. So we'll get rid of our answer and let's start a fresh capture, and this time we'll put in Chalk Farm, and that's correct. So there's the post request, and there's our Chalk Farm guess. So let's copy that and put here, and let's look at what we get back for a right answer. As you can see, the result, which was -1 last time, is now 1, and the player total is 3, which you'd guess corresponds to how many correct answers you've got down here. So let's copy that, and let's examine. So -1 is incorrect and 1 is correct, and of the other things in the query, the rest stays the same. It's only the guess that's changed here. So that's a correct and an incorrect guess for one particular station. So let's now try a different station. This one's fairly easy. It's an arch made of marbles, so it's Marble Arch. Let's get a fresh capture. And we'll submit correct. And there's our post request with the Marble Arch and the response, as you'd expect, 1 for correct, and we've now got 4 correct answers in total. So let's copy the query we sent. And let's examine it. This part is still the same, and this t equals 2 is still the same, but this c value has now changed. These two were for Chalk Farm, this is for Marble Arch. So it looks like the structure of the requests that you make is, we don't know what this is and we don't know what this is, but C is some code that refers to which part of the picture you're trying to guess, and G is the text of the station name that you've guessed. So now we should have enough information to be able to make a guess without using the browser. So let's find another one. Let's see. Okay, it's a cottage with a Swiss flag, so there's a station called Swiss Cottage. So let's start a fresh capture. And we'll just put some garbage in, because all we want is the code meaning that particular part of the picture. So that's wrong. Stop that. Post, there it is. So that's what we're interested in, this NT44PI. That is in some way the code meaning this part of the picture. So let's copy that and paste it down here. Now we want the actual website address as well, and then we can submit the whole thing as one web request. So that's available in here. Full request URI, lookforlonger.com game answers handler, that's what we need. Let's copy that, and so I'll put that at the front, and you just put a question mark to say this is the page to send the query to, and these are the arguments for the query. So if we change this, well actually first let's just try this as is. So we'll copy it, start a terminal, and we'll use wget to try and retrieve the data for that request. So suppress all the debug from wget. I'll just output it to the console rather than a file, and then we'll paste that site in there, and there we go, the int result -1 for incorrect. So if we now try it again but change the garbage to the right answer, you can see there we go, we've got 1 for the correct answer, and our total correct answers has increased as expected. So let's write a script now that we use this method to try every possible station until we hit the right answers for the ones I'm not sure about. So let's save this as try station. So we'll use Perl because it's a very good language for text processing. And we'll use this library that makes getting data off the web easy. So we need a variable for the guess code. That's that 5 or 6 character code we saw here, like this. So we'll have to enter this, and then it will try every station for that particular code. So for now we don't know what it is, or we could actually make it a command line argument like that. So let's make a function called try station, and this will try one particular station and return whether or not it's correct. So we'll get the name of the station that we want to try from the argument passed to the function, and we'll just tell the user what we're trying, and we'll get a variable called result which will get the result of the query. So that is this. Paste that in there, but obviously now we want to change a few things. So this will now be this guess code, and this will now be the station. So the data that comes back from this will be one of these, so we now need to parse it. So let's make a copy of it just for our reference here, put it in a comment. So we'll use regular expression matching to parse it. So M for match. Now what exactly do we need to parse? Well, we're looking for this part really, so we want int result colon like that, and then we want a number that could be negative because incorrect is -1, so we can use regular expression to say any number or the minus sign. So that will match to that. So we should check if this is true, if it did find a match. And if it did, we should check the result. But how do we get hold of this? This is the bit we're interested in. We don't care about this. Well, what we can do is, if we put parentheses around this part, we can then refer to it down here like this. Match 1 is what it would be now. So we can put, if that is equal to 1, then that is correct. So we can print and exit. And if it's not correct, we will just print and we'll continue. So that's our function. So let's put a few test calls in there to see if it works. So try station blah, try station hello there, and we'll actually put in a good station. So if we use this one, Marble Arch, we'll run it with this as the area to guess at, so it should return correct. So we can put try station Marble Arch. So if we save that now, and in our terminal make that executable, so now we should be able to run it with this as the code. And there we go. Blah and hello there obviously didn't work, but it managed to parse the correct response for Marble Arch. So all that's missing now is make calls to try station for every possible station, and then we should be able to guess the correct answer for any value for this. So to do that, let's go to Google and list of London Underground stations. There it is. So we can use the Wikipedia page. And there they all are. Here's all the stations. But it's slightly inconvenient, the fact that they're all in a table. So they're not straightforward to copy. But what we can do is Wikipedia allows you to edit the page. And in this version, they're much more manageable. If we look at each station title is very distinct, and that it's all the lines that start with scope equals row. So we can use that to our advantage. So if we copy the full URL, and we'll use wget again, so there's our web page that we want, but we just want the ones that have scope equals row in them. So if we run it like that, there they all are. There's all the tube stations. So you can see that each one starts with the name followed by tube station and then just the name on its own. So this is the part we're interested in here. So we'll use sed to transform each of these lines into a call to the try station function. So pipe it to sed, and we'll use the substitution operation in sed. But what do we want to substitute? Well, we have all of this up to the vertical bar. So in regular expression terms, we'll put any character up to the vertical bar, and then the bit after it is another any character up to double close bracket. So that's the pattern, and we'll replace that with try station, and in there we want to put just this bit. So we can do similar to what we did before. If we put the bit we're interested in parentheses, which is here, so everything in between the vertical bar and the double close, which is this, we can then refer to it in our replacement with /1. So if we run that now, we see we've transformed it into calls for all the stations. So let's get rid of our test ones, save that, and if we run all that and append it onto the end of try station, it's detected that the file has changed, so let's reload, and there we have all the calls to our station names. So let's now try the script out with a known state. So back with Chalk Farm, we'll copy the code, and then we should now just be able to run the try station script with that code, and it's trying them all, and there we go, it hit Chalk Farm and it got the right answer. So now we can actually go back to the game and pick one of the ones that I'm not sure about, or well, more accurately, haven't got a clue about, and see if we can do it. Now there's this one here, so it's a guy sort of holding a TV or a monitor with rope or maybe even spaghetti around it. It's very hard to tell, but I have no idea what this one is. So let's first use Wireshark to capture the traffic. Where are we? Here. Just so I can obtain the code for submitting for that part of the screen. So there it is. Let's stop that. That's what I need there. TU2071. So let's run it now. TU2071. 2071, and let's see what it comes back with. Right, bounds green. Right, I get it, that is dreadful. It is a bound screen. It is a screen bound with rope. So a bound screen is bounds green. Fuck me.